notes. If I were to ask you guys what the 3 main states of matter are, would you be able to tell me? And if so, you can type in the chat, or you can also just unmute yourself and speak. The 3 main, major, most common states of matter. Okay, cool, awesome. I'm seeing a lot of good responses here. Yeah, so you guys have this figured out, right? So solid, liquid, and gas, excellent. So you guys probably know like a lot about these 3 states of matter, and you probably know differences, you probably know similarities, and that's really what we're going to start Unit 4 with. We're going to start talking about liquids, solids, and gases, and then we're going to take it a step further, and we're going to go ahead and draw particle diagrams for these 3 things, okay? So like our main goal for today is to talk about solids, liquids, gases, kind of figure out the characteristics of them, and then be able to illustrate them with a particle diagram. Some of you might be saying, what the heck is a particle diagram? It's fine if you don't know, okay? We're gonna kind of figure that out together. All right, so we figured it out, solids, liquids, and gases. So let's kind of start talking about the characteristics of solids. So we're thinking in the back of our mind at all times here, what is going to be a correct drawing of a particle diagram for a solid, okay? And so basically, we've got some good descriptors here. Particles are touching each other, okay? They're going to be located at the bottom of the container due to gravity. You guys know all about gravity, right? You just came from physics, okay? So gravity obviously is going to affect solids. No extra space between the particles. They cannot be compressed, okay? I'm not entirely sure about this whole like why we're talking about they can't be compressed idea here. That's kind of interesting to me. So maybe hopefully we're going to come to understand why that's significant to us. All right. Solids are organized pattern, and there is no randomness in their particle diagrams. They do not spread across the bottom of a container, and they keep their shape. Okay, so normally I would have a couple of, kind of things to show you here today, but what I want you to envision for a solid is 2 dice, right? We're all familiar with dice. And you take a cup and you put 2 dice in the bottom of the cup, okay? So obviously we can kind of, bless you, we can kind of see a couple of these characteristics already, right? Those dice are not gonna change shape, right? They're gonna keep their shape, and they are going to not spread across the bottom of the container, right? They're gonna stay in their shape on the bottom of the container, okay? Let's see, are they going to be affected by gravity? Yes. Those dice are not going to float in the middle of the container, right? They're going to move to the bottom of the container. They're moving that way because of gravity, okay? All right, so we've got a couple of different examples. You guys can probably come up with a million examples, right? So my favorite examples are brick, an ice cube, and a piece of wood, okay? We have a lot of solid things that we kind of experience and work with every single day, right? Your desk or maybe a table that you're sitting at right now, that's definitely solid. Okay, so let's kind of move into liquids, and let's see if we can't compare and contrast liquids and solids while we learn about these characteristics of liquids, okay? So particles are touching each other, okay? So I think that that's a similarity between liquids and solids. Located at the bottom of the container due to gravity, that's definitely another similarity, okay? Some extra space between particles because of the irregular packing. So right off the bat, I am thinking that this, let me see, I think this color might work here, yes. So irregular packing, this is definitely a difference between our, between solids and liquids, right? Solids, remember we just said, it's not irregular packing. It's very organized packing, okay? So liquids could be a little organized, but not as organized as our solids, okay? Random organization of the particles, it's a little repetitive, spreads across the bottom of the container, okay? So this is definitely a difference between liquids and solids. All right, takes the shape of its container. Okay, again, this is definitely another difference between liquids and solids. Okay, so if you were to get 2 glasses, and let's say you get a really small, like a really short, like a coffee mug type of cup, right? And then you get a really tall glass. Okay, so it's like a really tall, glass that you might use for, milk or water or something, right? That liquid, whatever liquid it is, right? Say you're drinking on some orange juice because it's the morning. That liquid, when you pour it into that coffee cup, it's going to fill that cup from the bottom up, right? It's going to take the shape of that container. Same deal in a tall glass, right? It's going to take the shape of that container, all right? And that's a characteristic of liquids that's, pretty unique, especially when we're comparing it to solids. All right, examples, again, guys, examples for liquids are pretty easy to come up with. So juice, right, we just talked about orange juice perhaps, water, and then the ocean. Obviously, the ocean is full of water, but we could talk about maybe salt water or something like that. All right, last but not least, we've got gases. Gases are the weird ones, okay? They're kind of the odd mans out, and it's honestly just because they've got these more, a couple of more unique characteristics, okay? Particles are not touching at all. All right, so now we've gone from solid has like really organized particles, liquid kind of organized particles, gases, crazoid particles, okay, all over the place particles, all right. They are located throughout the container, and there's a lot of extra space between the particles, which makes them compressible, okay. Now, this is a huge difference between gases and solids. All right. So my favorite example of, can you guys see that pink on there? It's a little bright. Yeah. Okay. All right. So my favorite example of gases is thinking about a balloon, right? We've all had balloons before, whether they're filled with helium or whether they're filled with air, right? So, just think about maybe a balloon you've just blown up by yourself, and you can kind of take that balloon and you can kind of like push it, right? You can kind of make it skinny, right? Or you could squash it. You could squash it from top and bottom and make it skinny in the long way, right? And so that really is because that balloon is filled with gas particles, and those gas particles are compressible. I'm able to push them closer together. All right, here's the unique thing about gas particles. They actually don't want to be near each other, okay? And they're kind of like, I like to think of them as like 5-year-olds at recess. So like they've been in school all day or for like a few hours, and then the 5-year-olds get to go outside on the playground and they just like run wild, right? Because they have all this like pent up energy. So gas particles like act like that. They're constantly moving around this whatever container they're in, and they're constantly wanting to like spread out from each other. All right, I think this is my last slide. So random organization of particles. Obviously, if we have gas particles kind of like going crazoid, they're not going to be organized very well, okay? They're going to spread throughout the container, and they are going to take the shape of the container, okay? So kind of a similarity here between gases and liquids, right? Taking the shape of the container. All right, so gases, sometimes it's hard to come up with examples for these. I have a couple here listed. Maybe we can come up with some more. Carbon dioxide, right, which is CO2. All right, anybody know anything about carbon dioxide, like where it is or like what it does or like where it comes from? Anybody know anything about carbon dioxide? You can type in.
Is that what you breathe out?
Yeah, Jalen, that's exactly right. That is what we're breathing out right now. So I'm breathing out my carbon dioxide in my mask. You guys are probably breathing out your carbon dioxide in your homes, right? Anybody know what uses carbon dioxide? So we kind of get rid of it, right? Anybody know what uses carbon dioxide? Yeah. Plants. Yes, excellent. Yes, plants. So plants love carbon dioxide, right? And what plants do really is use carbon dioxide and water to produce something called glucose. Okay, now that's a more bio topic, but we'll talk about that maybe a little bit later on, and you'll definitely learn about that in biology next year. Okay, so great, carbon dioxide. Oxygen. Now I'm going to write the formula for oxygen. The formula for oxygen is actually O2. Okay, now if you're a little uncomfortable with the formulas, please don't fret. We're going to learn all about formulas in Unit 6 together. All right, but basically the oxygen that you and I are both breathing in right now is O2. All right, so what that really means is that there's 2 atoms of oxygen in the air that we're breathing in. Okay, yeah, good, oxygen. All right, my last example there is perfume. So we're not talking about when it's in the bottle, but once you spray your perfume, don't you see it kind of mist out before you if you spray it like pretty close to your face? So that is also kind of forcing that liquid perfume into a gas so that it can actually spread out those particles. Anybody know why I have this picture here? Anybody know what this is and why I might have it here? Okay, if not.
Because there's propane gas in it.
Yeah, so this is a propane tank. So those of you who might have a propane grill at home, you might have seen these tanks before. And what this contains is propane. Now, propane is C3H8. That's its formula. You don't need to know that, okay? I'm just kind of trying to throw some things at you today, okay? So propane, that's C3H8, okay? So that is another gas, right? You can use that in a grill. You can also use propane to do like a lot of other things. Like some people use propane to heat their homes, right? To run like their heating system and stuff like that. So propane is pretty cool. All right, guys, here's what I want you to do. Wherever you are kind of looking at right now, if you have Notability up or you have a notebook or just a scratch piece of paper in front of you, I want you to go ahead and draw for me a particle diagram of a solid, a particle diagram of a liquid, and then a particle diagram of a gas, okay? Kind of draw them all right next to each other so you can kind of think about the similarities and the differences, okay? So go ahead and work on that. I'll give you about a minute or so, and we'll kind of take a look at what we came up with. All right, so anybody want to kind of give me a description of kind of how they illustrated either solid, either liquid, or either gas? Anything that you kind of want to start off with?
I made my solid ones bunched together and like at the bottom.
Perfect. Yeah, awesome. Anybody want to add to that?
I made it kind of like a uniform square,
Aha. Okay, I like
It's-
that.
like stuck together.
Okay, like it's stuck together. Yeah, excellent. So hopefully maybe something along these lines. What I'm drawing here. I'm trying to illustrate that they are organized, right? My circles aren't perfect because we're drawing here, but I think I get the point across, right? They're organized. They're all located at the bottom of the container. They are touching each other, right? And they're all about, the same size, same shape there. Okay, great. Any questions or concerns on a solid particle diagram? All right, cool. What about a liquid? What do we got for a liquid?
They were all kind of stuck together, but like a little messy at the bottom.
Okay, cool. So kind of all maybe still touching each other, but kind of messier at the bottom than the solid. Anybody want to add anything else to that? The only other thing I would add to that is we kind of want to illustrate that they're kind of like spread out at the bottom of the container. I'm doing a poor job at drawing the same size circles. So, and this is maybe something you can make sure you illustrate with the solid. The solid is not spread out, right? It's only taking up like that middle space of the container. So again, anytime I think about drawing a solid particle diagram, I'm thinking about like a dice in a cup, okay? And so that's going to kind of show that that solid isn't going to spread out, but it is going to be at the bottom of the container. The liquid, right, is spread all the way to the sides, okay? And so that's something you want to just make sure that you are comfortable with illustrating there. The liquid, again, at the bottom of the container, like Tyler said, and then kind of like a little more random, not as, organized as that solid. Okay, great. Questions or concerns on the liquid? All right. What about our gas? What do you guys want to say about that?
I kind of just made it like crazy and all over the container.
Crazy and all over the container. Yeah, I really like that. So we'll kind of draw one up here, maybe one up here, maybe one over here, over here, over here. Let me ask you guys this. Did anybody draw them with like maybe like little marks after them to show that they were moving around?
The
I
marks
did.
indicate like speed, right?
Yeah, and like so a lot of students will draw these with little marks on them just so that they are representing that those gas particles are actually like trying to run away from each other, right? They're actually moving at all times, okay? You don't have to draw the little lines there. I kind of like it. Makes it look like rockets. I don't know. So, but if you would like to illustrate that, that can kind of help you remember those gas particles are kind of flying all over the place. Okay? All right, excellent job, guys. Any questions or concerns on anything we talked about today in our notes here? Everybody seems to be okay today. That's awesome. So let me tell you what your assignment is, and we will sign off here. I actually didn't go too long over the 20 minutes, so that's pretty good. I'm going to just jump back onto Canvas. Your actual assignment for today is to go back and fill in the States of Matter notes handout. Okay. And again, this is kind of going to be a common activity for us. We're kind of going to talk about something in class, and then I'm going to have you go back and read maybe a little bit through the notes again, and then just fill out this note sheet for me. Okay. And this is like a note sheet that you would kind of want to keep tabs on so that when we start to prepare for our Unit 4 assessment next week, you can kind of go back through your note sheet and, kind of remember what you highlighted, what you starred, what you thought was most important. Okay, these are how my notes are normally done. They're fill in the blank. So I hope that's, okay with you guys. And then, everything that you need for these notes can be found right on that PowerPoint PDF that I had posted there today. Okay. So what you'll go ahead and do, you'll fill out these notes. Okay. And then you're going to submit those. That's going to be your assignment for today. All right. How comfortable are we with submitting from Notability? Does anybody want me to talk about that at all? Or have you guys done that in your first semester classes and feel confident with it? Everybody feels pretty confident. Okay, if you ever have like a tech problem, you can ask me. I might not know the answer, but I'll try and figure it out for you. All right. The last thing that I'll say before I let you guys go is the way I make my due dates and due times is that basically you're going to have until the start of the next class to complete something. So we have class tomorrow. So the due date for this assignment is tomorrow. And you guys are section 1 here. You're at the top. You probably don't see the other things on your page. But so basically I have this due by like 8:35. So like 10 or 15 minutes into the start of class, you want to be able to submit the assignment from the day before. Okay. Hopefully you guys just complete this now during like your first block time. That's what I would really highly encourage. But obviously, if whatever comes up and you want to do this assignment later, just make sure it's into me before the start of class tomorrow. Okay. Any questions or concerns, guys? No? Everybody is okay? All right, my friends. So make sure you've typed